Well, I was feeling pretty distressed when I got the wrong answer at the end of the last video, but I figured it out that I actually typed into the calculator wrong. What happened was my cell phone was going as I was trying to work it out, which is why cell phones and math don't mix very well. So if you actually do the right numbers, it is not 22.36, it is actually 16.96%, which compared to what we got, the correct answer, 16.94%, is really, 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 really close, right? So the normal approximation, so this was a binomial distribution. If we did it using the formula, we got 16.94%. With the approximation, turning it from a discrete value into continuous and doing z-scores and looking it up on the chart, we got more or less the same answer. And that's kind of impressive. So the question is, when would you use this, and when would you use binomial, and when would you use the approximation? And the reality is you could use either whenever you want. So let's take a look. In the example here, we're going to decide which one we want to use. Do we want to use the normal binomial formula, or do we want to do the normal approximation? So what we have here, we are going to success n p q x. Okay, so a success, an 8-sided die is rolled 200 times. What's the probability that 2 will be rolled at least 31 times? So success is going to be roll a 2, right? Roll a 2. N is going to be 200. The probability of rolling a 2 is 1 out of 8. The probability of not rolling a 2 is 7 out of 8. And we want to roll it at least 31 times. So it's got to be 31, 32, 33, 34, all the way to 200. Well, that's going to be ridiculous. So we know what to do here. What we're going to do is we're going to do, indirect. And we'll say not x. So not x is going to be 0, 1, 2, 3, 4, all the way up to 30. And that's still kind of yucky. Right, we could do it. We could do it, but there's lots of cases. There's lots and lots and lots of cases. So so this is a situation where it might be useful to use the approximation, right? So what we're going to do is we're going to figure out, first of all, can we approximate it, right? That's the first thing we need to figure out. Can we actually even approximate this thing? So can we approximate? Well, first we're going to check NP. So NP is going to be 200 times 1 over 8, which is going to be 25. And NQ is going to be 200 times 7 over 8, which is going to be 175. Are these bigger than 5? They are much bigger than 5, which means the approximation is probably going to be pretty solid. So therefore, yes, we can approximate. And then we could, now our assumptions are going to be that the mean is equal to NP, which is going to be equal to 25. And the standard deviation is going to be the square root of NPQ, which is going to be 200 times 1 over 8 times 7 over 8, which is I got 4.677, so 4.68. Okay, so it's going to be 4.68. So now let's actually use this thing. So what it's asking for, we want the probability of being at least 31 times. So that's the probability of it being greater than or equal to 31, because it's at least 31. So 31 is okay. That's discrete, so we're going to have to do a continuity correction. So it's going to be the same thing as being bigger than 30.5. we're going to have to do a z-score calculation. So the z-score is going to be our x value minus the mean, which we know is 25, divided by the standard deviation, which based on the approximation is 4.68. So 5.5 divided by 4.68, which is going to give us 1.175, so about 1.18. So this is going to be, that should be a probability. The probability that z is bigger than 1.18. And because it's a bigger than, it's going to be the probability that z is less than 1. No, it's going to be 1 minus the probability that z is less than 1.18, which is going to be 1 minus the z-score chart, 1.18. 1.18 is 8810. 8810, which is going to be 11.90%. And there we go. So if an 8-sided, ooh, I went off the page there, but that's what it is. So if an 8-sided die is rolled 200 times, what's the probability that a 2 will be rolled at least 31 times? And the answer is going to be 11.9%. So when's the approximation useful? Generally when there's a lot of different cases, and instead of doing 30 or 31 different cases, you could do it as a normal approximation, and in this case get the answer a lot faster.